Okay, students, here's another little video on atomic structure, and it's going to have a little bit to do with percent abundance of isotopes as well. So if I'm kind of doing this part here on one of the pages of those notes, but first periodic table is made by a guy named Dmitry Mendeleev. One thing about his table is he only knew of so many elements at the time, and he left empty spots on his periodic table where he thought elements would be discovered. He could describe those elements to a T. Like he would tell their melting point, could tell what color they were going to be, could tell what elements they would react with that were around at the time. And the reason is because the properties of the elements repeat themselves. Okay, they're periodic. That's why it's called periodic table. So here's this little thing here. Draw an atom with 7 protons, 11 neutrons. 7 protons, 11 neutrons. So if we're going to do that, we'd say, okay, oops, get a pen going. So 7 protons means it would have 7 protons in the nucleus, 11 neutrons, 7 electrons if it's neutral. If I asked you what element that was, you look in the periodic table and figure out what element number 7 is. Element number 7 is nitrogen. Okay. In this case, it would be nitrogen with a mass of 7 plus 11. Only stuff in the nucleus has mass. Be nitrogen 18. Be that isotope. So you might see nitrogen 18 as that. You may also see this written. You may also see the 18 written right there, which is the mass number. And sometimes the atomic number down there. So if you see this, called symbolic notation, atomic number, mass number. Atomic number, mass number. If you see just that, that's just the mass number. Remember, the atomic number for nitrogen will never change. Draw an atom with atomic number of 10, mass number of 23 AMUs. So if the atomic number is 10, that means we have 10 protons and 10 electrons going around the outside of the nucleus, free to move. Mass number is 23, so that means the stuff in the nucleus has to add up to 23, so it must have 13 neutrons. Look at the periodic table, see what element 10 is. Element 10 is neon, so this would be an element of neon with a mass of 23. One more on here. Atom with 4 electrons. If it's neutral, that means it also has 4 protons, which means it is an element of beryllium. So this would be beryllium. It's got 4 protons. 10 AMUs means there must be 10 things in the nucleus. It must have 6 neutrons. That'd be beryllium 10. Not the most common isotope, beryllium. If you look in the periodic table, 9 is the average mass of beryllium, so its most common isotope is beryllium 9. All right, one more little part here. Figuring out atomic mass. So this is telling you the percent of elements of each isotope. So this is saying this percentage of copper weighs this many AMUs. So of all the copper isotopes on Earth, 69% of them weigh that much. The other 30.9% weighs this many AMUs. Okay, so that percentage weighs that much. So if we think about the average of these two, the average has to be between 62.9 and 64.9 AMUs, the average weight does. There's a lot more atoms that weigh this than this, so our average should be closer to that number. Now, it's hard to find. We can't just add these together and divide by 2 because there's a lot more atoms that weigh this. So if we're doing this, if we're finding the average atomic mass, the average mass of all the coppers, we got to take the percent of one isotope times the mass in AMUs plus the percent of another isotope times the mass in AMUs. And there might be more than one isotope. There might be more than 2 isotopes. There might be 3 or 4 or 5 isotopes. And our percent needs to be as a decimal. Okay, percent needs to be as a decimal. So if we do this, take this percent, which we just make it 0.691, times 62.93 AMUs, plus, you can just type this right in your calculator, this percent, 0.309, times 64.93 AMUs. Again, our average should be between 62.9 and 64.9, but it won't be right in the middle of them because there's a lot more of these atoms than there are of those atoms, so it should be closer to this. If we do that, type those in your calculator, average is about 63 0.5 AMUs. That is the average of all the copper atoms on Earth. Well, if you look on the periodic table, that should be the number on the periodic table also, as you're doing these things. All right. There's another example of that down there. Type it in your calculator, you can get an answer from there. That's all we got for today.